download didn't work. Okay, go. Oh, a grid. Step counter, blah blah blah. Plots of carriage 64 steps. Puzzle input, starting position is S, gardens and rock, or elf starts a starting position, count as a garden, take one step, but only onto target my garden plot, which is a hash. Either the second step will to reach any garden plot. Okay, yeah. Wait. Second step of any tile could have reached the first step. Yep, that makes a lot of sense. Okay. And think of these more possibilities, etc., etc. Uh, get exactly 6 more steps to use them to reach any of 16. However, 64. Okay. Starting from a garden plot, how many garden plots could the elf reach in exactly 64 steps? Trivial. Okay. So let's start by reading the grid. So grid equals a grid dense read and grid dot print. Let's test that. Okay, the grid has been read. Okay, now I need to find the S here. So yeah, grid iterate sub. So it gets row column and value, right? My R C V equals uh, S R S C if value equals S SRSC equals RC, debug SRSC, run, what does it do? Okay, 65, 65, excellent. Now also do a grid set, yeah, set RC to hashtag. Okay, do I need to make it sparse? No, I don't think so. Okay, good. Now, next, wait. Okay, yep, next step is I need to uh, iterate. So I need to my uh, uh, list equals SRSC. It's gonna be list of coordinates. Yep, okay. And now I need to do for I want to 64, my end list for my $x list. Now I need to, actually, let's use the string version. It'll be easier. Okay, for my $n, grid one of x. Is there anything else I need? No. And that will give me my nr nc nv equals $n. Okay, we need to do that now. Next if nv not equals hashtag. Okay, and now just push n list nr nc. Right. Then list equals n list, and just out scalar n list. And just for prettiness, let's not n list, list. And that should be the answer. Okay, errors, unusual value nv in 21, uh, line, it's 46. 46, yes. Okay, row column value. One doesn't return me a row column value. Let's, maybe not. My NV equals grid at, oh no, it's, okay, no, sorry. It's like this. It's smarter than what I thought it is. Okay. Okay, that doesn't return anything scalar. It's just 0. Okay. Debug nrc calls nrc nv calls nv. Is it not what I think it is? Nrc calls. Okay, so that means the S is surrounded by dots and it immediately ends. That's weird. Uh, S is surrounded by dots. I misread the question. Okay. Uh, tiles onto tiles are our garden plots, north, south. But S is in the middle of nothing, so how could it do that? And the second step, it's the other way around. Okay, I misunderstood what dot and hashtags are. Okay. Okay, remove the debugging print because that's a lot. Oh, really? Is this too slow? That's surprising because I mean it shouldn't be that many. Oh, shoot, not list, not list. Uh, oh shoot, and hash of nrc plus plus list is keys and hash. My bad. Okay, correct. Now part 2. 400. Wow. Okay. Mistake. I was reading from this favorite number. Actual number of steps is way bigger. The map repeats infinitely. Oh, so if you look at one addition, and find it repeating in every direction. I see. And tiny 3x3 map, infinite farm garden plots. Okay, yes, okay. Of course it will. So this is definitely interesting what I'm seeing here. As it seems like we have a nice lattice here. So, because I can see the actual input, what it seems like we're actually doing is just drawing this big lattice. So all I have to do is find that lattice and draw it. Okay, so interesting. Let me think. So the size of the lattice, as I can see, if it comes from row 1 to row 129, so 129 rows, which is, yeah, so it's basically, it's the number of things plus 1 is the total length. And okay, now let's, okay, first of all, let's convert it. And it keeps continuing, so all I have to do is, so I need to mark it on this map, and I need to find the corners. So let's start by doing the obvious, which is filling the grid itself, and that's basically an every, again, I can hard code it to the problem, so 1 by 65, it's an even position. So every position that has an even Manhattan sum I need to count it, so I can do it right here. Uh, da, da, uh, okay, then I need to do the following. Dollar sum plus plus if uh, R plus dollar C uh, uh, and 1 equals 0 and dollar $V equals dot. Okay, and now I can run this first of all. 0. That's 0 is not the right answer. Uh, R plus C until 1 equals 0 and B equals that. Why is this? Okay. And V equals 0. S dot. How can it not be ever that? Uh, yeah, okay. RCV. Okay, yeah. Why did that doesn't make any sense? Uh, what if I use that? What's going on? This is weird. Okay, yeah, this. I'm not sure what's going on here. I'm very confused. Okay, so this is the first value. Now I need to tile. So I need to tile the plane with this number. So and then I need to calculate the corners. So okay. So again, this is 131 by 131. Does that mean it's a little off? Yeah, it will be, but okay. So now the answer, or the question is, I need to just calculate the edges. So, okay. So I have, how do I do this? I need to do the following. So, okay, I have this number. That number is useful. I'll put it here as a, because that's the first number that I need. Now let's figure out what we're doing next. Next, what we need to do is figure out how many, yeah, now So I need modulus. Okay, so there will be a whole bunch of edges that I need to draw, and I need to check all of them. So, but now forget about doing this process. First of all, let's create a new thing that will draw the same thing but faster. So that will be essentially, I'm going, the maximum distance is 64. So, and just the question is how many we're going left or up. So for my I 1 to 64. So I'm gonna do the similar thing. Forget about the hash. Forget about the list. Forget about this. Uh, and I'm just gonna do a simple thing, which is, let me think about it. Okay, I goes to 2064. How many steps you've taken? Wait, no, this is, have you taken, okay, okay, let me think about it. Keep saying that, but I'm not doing that. So the total distance from the start basically is between uh, 0 and 64, either way, because it's an even number. 0 is also there, right? So I can be distance 0 and 64, and then for each distance, I need to draw all the options, and that would be for j is from 0 to I. And now what I want to do is, okay, now row, so let's start with a quarter of the area. Row is, so you've walked a total of I steps, and j of them you've walked in one direction. So row is I minus j, and column is j. But then we need to also obviously add the starting position, which was 65. So that would be that, and just that will show a quarter of this graph. Let's double check that. Oh, okay, so that's a full graph, which is wrong. And it is, okay, so now, okay, next, if I and 1 put holes in it, okay, great. That looks good, except now it's only a quarter of the graph, so I need to do several options. So that's this one. Now, same thing, but the row is negated. And the same thing, but okay, the row is negated. The same thing, but the column is negated. And the same thing, but sorry, this is both of them are negated, and this is only the column is negated. That should create all of them. Okay, yes, that's, is there doubles here? There would be, because if j is 0, then several of these are the same, but so if j is 0, I only need these, wait, which ones do I need? I need this one. Uh, one we've already done, and that one we've already done. Think that's correct. Let's double check. Nope. Wait. I mean, not unless, I mean if, of course. Okay, that's good. Okay, so we have something that finds all the things. Also now, yeah, and then I need to obviously remove the things. Now I need to basically only look at the ones that are outside. Actually, can I choose it? Yeah, okay. So, okay, now, actually, uh, okay, okay, let's forget the plus 65, and then let me just do this a little cleaner. So, okay, okay, think about the problem, okay? And okay, so we have R, okay, we have RC, we have minus RC, minus RC. We have, actually, yeah, that would work surprisingly, and minus R minus C, and then now this will be shifted so it won't work properly yet. What? Uninitialized value RC. Great. Okay, yeah, that's fine. Okay, yeah, because this will do that, but it will do this shifted, which is not a problem because now I need to do the okay, sub mega grid RC equals whatever, and I need to know if this is that or not. So mega grid, I need to do the following. So first of all, so R plus equals 65, C plus equals 65, center them. Then R percent equals 131, and C percent equals 131. Return grid at RC equals dot. Okay, and now if mega grid of RC, okay, and now, yeah, now this will still be wrong, but, okay, yeah, it moved around, so I need to fix that by, just to check map, dollar. Ugly. should work. Oh, it doesn't work. Uninitialized UO, because that's that. Syntax error because of that. Okay, is this correct? No, it is not correct. There is a problem in MegaGrid land, and let's see what's wrong. Because it should return true if it is equal. Clearly, the MegaGrid is not where it's supposed to be. Because, yeah, it is not creating the right values. What is going on here? Why is it not? Oh, shoot. Yes, okay, fine. Okay, is this correct now? Yes. Okay, great. Now that we've done that, great. Now I can reset sum to 0 and basically just go the entire distance, which is this. Uh, Doing this squared is kind of big, but it's not that big. And I think it should be fast enough. Uh, and we'll see if it's not, I'll, I'll later see if it's not good enough. Can I memorize? I can memorize MegaGrid, no, definitely. Can definitely memorize MegaGrid. And hey, yes, I think I do need to do it a little better. Yeah, this is slow. This is slow. I mean, it will eventually finish, but it's slow. So let's find a better way to deal with it. The better way to deal with it is to, as I said, skip this for coordinates that are in the middle, because we have the tiling for the middle, and then we just need to figure out how this looks like. So we have a diamond shape like this, and the grid is smaller. So actually, yeah, let me look at this output again. So what we will have here is we have a big diamond, and I'm looking at it in parts. So the parts that are in the middle, I can completely ignore. Uh, Now, is the size, and the grid is tiling in a certain size, but the diagonals I will need, well, they will still be 45-degree diagonals. So I guess I can try to solve it tile by tile. Uh, and that because, huh, how do I solve this cleanly? Because, yeah, this would work, but it's extremely slow. So it will not finish in a reasonable time. I need to create, I have the answer for the number of spots for 7,000, etc., for a full grid. The thing is that we are not dealing with just full grids because there are the diagonals. Uh, it seems like in this, Okay, this input is interesting in that the grid can be broken up into parts. I see. Like this grid is very carefully designed. There's one, two, three, four. There are these triangles, and I need to do some writing on paper. I have paper. I do have paper. Sorry, you can't see my paper. Now let's see. I'm gonna. Okay, so we have a bunch of. Actually, I need graph paper, but okay, we have a bunch of that, and we essentially have a diamond here, right? So what we're counting, okay, and I assume this number is divides nicely into, let's, yeah, now this will not never finish in time. So let's go back to then. Factor this number for me, please. Fine, if you can't do it, Wolfram Alpha can. Not Wolfel Alpha, Wolfram Alpha. Factor this for me, please. Uh, hmm. 5 times 11 times a big prime. So it doesn't exactly match there, but that shouldn't matter, right? Well, let's see. Because this is 131 by 131 is the, uh, wait, yes, that's what I thought. Okay. It's a bunch of stuff times 131. So yes, it does fit exactly there. So the important thing is, okay, I need, I need to draw some stuff. Wait, okay, so let's start. This diamond, uh, it's, no, it's x plus y equals, and let's say a big number. Come on, let's, okay, ridiculous, but that's fine. Okay. Mm-hmm. And then there is x minus y equals the same value. That's the second end, and then minus x minus y equals that value, and then there is minus x plus y equals this value. Okay, and that's the diamond we're drawing. And now let's look carefully at the grid lines right here. So what we're doing is we are having so we're two half grids, and it's okay. So I need to calculate every quadrant, and then I need to figure out what we're doing. So, because there are 4 quadrants of the grid, and I need to figure out how to solve this. Okay, so let's think about this. Don't need to make a grid, just look at this grid and figure out. Okay, so okay, so let's see. Quadrant 1, 2, 3, 4, 5, 8 quadrants. Okay, so let's solve this. So, do I need all 8 quadrants, or can I be more careful? Actually, no, it's just the regular grid. I don't need to break it into quadrants because if I look at sideways, these will be a full number of full grids because they will add up and cancel each other. Excellent. So this is the full grid times just how many times it appears there, right? So how many times does it appear there? Is this correct? I think so. Yes, actually. So full grid, which is this number we have here, 74363, times essentially it's this number, right? So uh, how many times? That's the only question. How many times does the full grid appear here? So let's find the area here. The area here, it should be relatively simple because this length is just twice times that big number, right? So the area is, okay, so the area is this number squared times 4. That's the area because, yeah, that's the area because it's this number, but it is, yeah, because this is this number, this is a number. So I need to do it. No, wait. Careful. The length of this a and b, a squared plus b squared equals c squared. So so the area is not like that. It is, or it's the square root of 2 here. So the area of this, well, it's these 4 triangles combined. And the length of the triangle is base times that, which is this number squared. That's the length of, that's the size of the triangle divided by 2 times 4 is 2 times this, not 4 times. It's 2 times this thing. Okay, so this number squared times 2 because I packed the triangles neatly and then it is 2 times that big square. Okay, that's the, now how many, and the size of a single square is 131 squared. And this doesn't divide equally, which is weird because of the 65 shift. And I need to figure out exactly what happens with that shift. Because 130, because yeah, 131 squared is the size of a single grid square. And my question is how many full grid squares will be in there? And the answer is it's not a round number because of the 65. Let's, now if I get rid of the 65, let me just try this number. Just try this number. I'll take this number, multiply it by our, I don't think it will be right, but it's a number I want to try. No, it's wrong. Not the right answer. Okay. Okay, yeah, that's wrong. It is, I don't know if it's too big or too small because I'm still fast. So, okay, that's wrong. I thought it would be, but because why reduce the 65? That's, but again, it's very suspicious because, okay, so it's that plus 65. So you're doing all of that movement plus another half. So you're breaking, yeah, you're doing that plus another half. So is it just that plus part 1 solution? Then that's a guess, but let's try that. Add to this part 1 solution. Part 1 solution. And let's try this one. Again, this is a little bit of a guess, but I'm doing some guesswork before. No, still not the right answer. Okay, shoot, 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 shoot. Okay, this is not going to be an easy one. I can already tell you that. Oh yeah, we have an example. So let's try the example here. Do I want to really do the example? The example grid size is 12 by 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 by 11. Yeah, the example grid is 11 by 11. The okay. So I need to figure out what we're gonna do about it. Because we are just trying to, again, figure out the area of this thing. So we figured out the area of that entire shape. Now I need to figure out how these map onto it. And the answer is, well, there are, let's think about it in terms of half, that's the thing, is that the 65 line is weird like that. It's because this is an odd number. And go back to this. Yeah, so the big number minus 65 has a nice divisor by 131. That's not an accident, right? So again, this is the graph of where we're searching. And now what we're doing, now where would it hit on the grid? If I'm going something 130, it will hit at the edge of it will hit, because it's plus 65, it will hit at the top of, so there will be like this. Yeah, that will be, the top part will be a hat. Will be everything full except these tops. And the bottom will be the same thing, everything full except the bottom. The side will be everything full except that, etc. Those will be the four edges. Then we will have, okay, let me think. So if the top one looks like a hat, okay, then below it, this is completely full. This would be, right, like, so this would be like that, that. Then the one below it will be, again, one of these, three of these, one of these. So, okay, now that would be this side. This side will have these, etc. So, okay, we have the four directions. And how do these add up? So let's try adding them up. This one, so there will be on this side, for every one of these, there will be one of these. So these cancel out or add up to a. So let me just, again, let's reshape the diamond and crumble it into a box by cutting in half like this, and now putting this over here. So basically, we will have a, you can't cut in half here because this is in the middle of a This is in the middle of the thing. That's the problem. So what? So what if it's in the middle of the thing? Let's do it anyway. Okay, so we're cutting in the middle of the thing. What do we see? What we will see is we will have big square, big square. Now this is middle of the field, middle of the field, middle, middle. So the corner's on the middle. So it's just filling up, right? So it should be, because now we have, oh wait, it will be half the size, right? So it will have like this, and like this, and like this. So, because we broke the thing into, so it will be from mid to here to mid, because these are all middle of the thing. So basically, let's rethink the tiles, remove them, and make them so the S is in the corner rather than in the middle. That's the main thing that we need to like rethink ourselves. It won't be any different, it will be the same tiles. And the S is in 0, 0. Okay, so what we're doing, so we're fully doing these number of tiles. It's a full, so these are full tiles. How many of them do we have? So here we have big number divided by 131. Here we have two big number divided by 131. So it's, yeah, wait, so this should be exact. Why? Okay, the big number divided by 131. Wait, big number is not divisible by 131. That's what we're trying to tell you. It's not big number. What is big number here? Because, yeah, big number is not divisible. Why is big number not divisible by 131? Because of the plus 65. Because, okay, again, this should be easy, but I'm not getting it. Because, okay, so the actual original grid, let's shift the original grid. Still, the actual original grid is still half of, even if we shifted the original grid, something is weird here. Because there is like an odd one out in the middle, is what I'm trying to say. Again, go back to this. We're starting, let's again assume the grid is already shifted. So we have four of these, and the first diamond is like this. Now we're trying to do a really big diamond, and again, the distance is still, we start at 0, 0, but the distance is still plus 65. That means the distance is still what exactly? So let's start with, we started at 0, 0, and we did 65. Let's start with a simple case. We started at 0, 0. These are the four copies of the grid, and we did 65. We went to half the grid in each direction. Okay, great. So far, so good. Now we do one more full grid. We do one more full grid. It means as follows. It means now this adds one more full grid, and the head is here, the head is here, head is here, the head is here, and now we are in a bigger situation. Okay, so this is, so the thing is the head is still half a grid. That's the big takeaway here that we need to think of. because this was not quite the correct drawing, because what we will have here is at the end, this is just a quarter. It takes, it just ends in the middle of the grid there. So, and exactly if we, so what are we adding to? Because if we went without the plus 65, then this would be correct, right? Because if the number was 131, if the number was 131, we will be doing two full grids, right? Because we'll be doing, let me just check the number for 131 just to, because this is a small enough number that I can just run it. If the number was 131, we get 15, which is two full grids, 7463 times 2, yes. Uh, no, it's not correct. Why is it not correct? Because there is one more step here. Huh. Wait a minute. Oh, no, from 1 to 131. Yeah, that's... Yeah, let's run it again. Still wrong. Okay, weird. This is weird, and let's be careful here. Because if you're going 131 steps, you're not covering the entire grid. Why? Or the entire grid twice. What are you covering? If you're going 131 steps, which is the size of the grid, what exactly are you doing? So let's think about it. You're starting at the middle between these four grids. And your diamond is like this. Full size of four grids. You would think, but there's an off by one here. If it was 130, would that be correct? What? No, that can't be the case. What? How is 130 and 131 the same answer? Oh, because, yeah, you need to always go an even number. Wait. I always has to be even or odd? Let's remind myself what's first example, 64. Yeah, it has to be even. So 130 is that, but 128. Why is this not ever the same as the 7436 that we calculated? Maybe it was wrong. Okay, there is a chance that what we calculated before was wrong, which explains why our initial test was wrong. So if what we calculated before was wrong, the actual number needs to be 7554. And just that needs to be, okay. So now all I need to do is multiply this by 7554. And we still need to deal with the, let's try this answer first of all. No, that won't work because there's the extra 65. Uh, right? This is the value we get if we, this is not including the extra 64 steps. What would the extra 64 steps give us? A lot of headaches. That's what they would give us. But because it's another half. Uh, but yeah, basically it should be the A part. I think this. Did I calculate that wrong? Let me try this answer and then figure out what I'm doing wrong. Okay. Ah, is a mess. Okay. Redo this from the start. Think about the thing. Let's try a much smaller thing. Okay? Let's try much smaller. Okay. What is the number? So let's take 131 times 100 plus 65. 131.65. Let's see what the answer. Wait, 64. 131. What was the actual number that was written there? Ah, come on. What was the actual number? Wait, it's an odd number. It's a freaking odd number of steps. Jesus. Oh my God. It's an odd number of steps. That changes everything. Oh, shoot. It's an odd number of steps. It's a freaking odd number of steps. That changes everything. It's an. What's Jesus? Anyway, I need to. This is an odd number of steps. That's bad. Okay, let's try this. Okay, push list of and the chord. Oh, okay. That's something that is important, and I didn't realize how important it is. Uh-huh. So yeah, this is okay. That's that. Let's try 65. Uh, okay. Yeah. 3883. Okay, so 3883 is the 65, which is the number I should have used to begin with. 3883 is 65. Okay. And what's the number? Uh, okay. Okay, okay. Okay, yeah. So now let's try it with 131. 131 is this odd number. Okay. Uh, let's do the calculation I thought I was doing before, but I need to do it correctly now. Seven three eight six is the correct number. Yeah. Okay. That's the 7386 is the odd number. Now, what? How is this 7386 times 2? No, it's not the. 7386, and then there's 3883. One 131,065. Shoot. Uh, fine. 131.65. Shoot. Okay, you're slow. I understand you're slow. So, okay, 131.65. What would the number be? Uh, okay. 1375. What would the number be? 10 times 131 plus 65. Okay, this is 164.0. Okay. Okay, now I need to find what this number is. I have two important numbers, 7386 and the 65 number right there. 7386, 3883, and 1640873. Those are the three numbers I need to connect here. So, and this should be something times 10. So 3883, so 1640873 minus 3883. Okay, we get this number. And this, because, okay, what I'm saying is there's the 65, and then there's the 131. Because you're going a certain number of 131s and the 65. Actually, let's see how much it will grow. Okay, so that's for 1375. Let's try 1310. We know these are correct for the small values because that's how we built them. Okay, what's the difference? Again, we think it's going to be the big number squared, some big number squared times times something. So okay, different difference between two squares shouldn't be. Okay, so is this divisible by anything interesting? Can you factor this for me, please? Prime. I don't like that. Okay, again, because there's two parts here. Because 65. Yeah, basically. And yeah. Wait, that's maybe how we. If this is the correct function, which I believe. No, wait, because that's why megagrid is here. Again. Because again, the usual thing is just half of 6, something like that. That's just. Like, how did you get to 4488? If we can figure that out, we can figure out the other one, I think. Because 4488, it is. Again, because 3883 is the number we found in 65. However, if we do all of them, that number is 4488, which is how do we get to that number? So the 131 squared is the. I want to see that drawing again. So let's run it again on 65. I want to see exactly how this looks like. And I also want to make sure it's correct, but I don't have my old code, sadly. Okay, that's. Oh, remove the list. That should be right, right? So, and let's see, the starting position, the place where it all started, it should be blank because you can't get there by walking an odd number of steps. So 65, 65. I wish the S was still there. Yeah, this is going to be impossible for me to notice. But, yeah, okay. Yeah, this is black. That should be like, okay. This looks correct for 65. Now, okay, if this is the correct calculation, and I need to double check that megagrid, yeah, megagrid works because that's how we tested it here. Uh, so now I need to, I don't know. Let me see the 131 grid. I know it will be way too big for my screen. I'm gonna manage, I promise. Oh. Mm-hmm. Yeah, okay. It's doing some silly, can't concatenate them. Okay, never mind. Oh, I know why. Yeah, okay. Let's not bother trying to visualize that. I'm not gonna bother with that mess. Okay, let's delete those things. Okay, but again, let's go back to this. This is our standard diamond, and the number is 3883. So far, so good. And we have numbers, the, wait, where did, okay, yeah, say if I 131 equals 5. And so how do we get to 4488? Can someone tell me? No, don't tell me. So there is an odd number here, right? Because what we're doing is 1 to 65 is the number. Why is it 1? So, no, we're doing it 65 times. No, no, no. 1 to 65 is a meaningful thing here. That is 1 to is this the total distance we walked between 1 and 60. No, we always walk 65. But I is the total distance we ended up, cause how many times we doubled up. Did I check the original algorithm to see that it works correctly on odd numbers? Because when we're doing an odd step, first we're going here. An odd step we're doing there. So yeah, because I mean, we're doing that and then we're doing even steps from that on. So that should be fine. I mean, this shape is the correct output. Did I? And I don't think so. Yeah. How does this work again? 1 to 65. What is that number is? I mean, so because we can get the distance up to 65, but that's not what I and J mean here. The row, oh, to draw a quarter of this, wait, wait. Am I counting double again? Did I not, did I remove the, I'm counting double, am I? Oh, shoot. Oh no, no. Yeah. We're seeing double. Oh my goodness. How is that the same? Oh, the sum is, but not a scalar list. Wait, how is this the same number? Didn't we just say we saw double? Oh, no, it's or die. I meant and die. Okay, no, we're good actually. Okay, okay. Again, 3883 is the correct number for uh, for this diamond. And the correct number for the full grid is 7386. Now, again, let's try to figure out what 131 plus 65, what should 131 look like first? No, 131 plus 60. 131 means, again, the grid has an odd size. So 131, you know what, let's try, uh, I'm only looking at odd eyes anyway, so it doesn't matter where I'm going. All right, so, again. again. First of all, let's look. Just yeah. Okay, that's just 8 times my triangular numbers. Okay? That's the basic. Ooh, n times n plus 1. Interesting. Okay. Now, the. Mhm. Why is, why is it 8? After one step, that shouldn't be 8, right? Right? What's going on here? This should be only 4. How did I get to 8? Why am I counting double? Why am I counting double? Okay. Okay. Is my function bad? Oh no. Oh my goodness. Minus frickin' 0. Oh my goodness. I forgot. Doesn't do. Okay. Okay. That explains why some of my previous things went wrong. 65. The correct number is 3751. Is the correct number for 65. Not what I said before. Oh my goodness. This should be a lot easier this way. Okay. Now, what? Why is it not printing correctly? Huh? Oh, eyes even, we don't count it because we're not interested in even eyes, which is fine. Okay, okay. hmm That's okay. So 65, wait, no. Oh yeah, because it's dividing by 131. Am I actually wanting to divide by 131? Yeah, there are 131 lines in here, but we're starting in a weird position. So they're numbered from 0 to 130. But no, it should be modulo 131. That is the correct modulus, I believe. Okay, so let's see what's going on. 3751 is the correct number for 65. 7, 3. So now, so now let's see how much it should be. So we know what it is for 65. What is it? Should it be for two grids plus 65? Okay, so we're getting two grids plus 65. How does that look? It looks like this. So we have starting position is here. I'm going one grid, two grid, half grid. Okay, and what we're drawing is this. Okay, now let's see. So the quarter of it is this. So this, okay. So on the top we have a half grid, something like this. Then below it, something like this, right? To its left, another one like this. Okay? Is this correct? Yes, I think so. So this is bottom three quarters. Okay. And then I need more paper. Okay. So again, I wish I had graph paper. I know I have graph paper here somewhere. 1 second. I didn't find graph paper, but I found ruled paper, so I'll make do. So again, we need, again, we are building this would be a 6 by 6 is what I need to do and to understand this. 4, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. And now this is a quarter like this. This one is a quarter like this, right? Because this is a quarter like this. This is a quarter like this. This is a quarter like this. Now these are quarters in the opposite orientation, etc. Okay, so let's look at this. So what do I have here? On just this corner, and all the other corners are similar. So again, if we look at the main a single grid, you can divide it into, wait, this is less than a quarter, it's an eighth, yeah. So we have part 8, we have all but 1, we have another 8, we have another all but 1, we have 3 eighths, 2 all but 1s, and 1 full. Now in this section, we have a 5. Okay, so this is in this section. In this section, it's the same thing, except instead of eighths, we will be having, so we got 1, 2, 3, 4, 5, 6, 7, 8. So in this section, it's the same thing, except we're having 5 and all but so here it's 5 and all but wait. No, these are 4s and all but 5. 4 and all but 5. Yes. Okay. Then here, these would be uh, 5s and all but 4, right? Five and all but 4, and these will be again 1 and all but 8. If you add them all together, you don't get, okay, so this matches with this, creating a full, this matches with this, creating a full, but these do not match and create a 1, 4, 5, 8, which is minus, so that's full minus 65. Okay, how many fulls does that give us? 1, 2, 3 times 4 is 12. 13 fulls minus a 65. So if I'm correct, this number, 107, 93, etc., should be 4 times a full minus a 65. And it isn't. Wait. Not 4, 12. Still isn't. Much closer. Let's start. Okay, 1, 2, 3 times 4 is 12, and then 8, and then, yeah. Not 12, 13, what I said. That's still wrong. Ah! It's still wrong. It's much closer, but it's still wrong. That number means nothing to me. Why did I do wrong? Okay, okay. Let's try. mm, Let's try something simple. What should 131 be? Like it's 131 plus 65 is what we really care about, which is 196. Okay. Let's try this again. Okay. 131. What does, okay. 131 means that you're, okay. Why is 131 not the same as a full grid? It's way bigger than a full grid. Why? Because why is 131 not the same as a full grid? Did we count the full grid correctly? Did we count 131 correctly? And did we? Okay, yeah, just, hey, again, need to be careful here. What is, this is 131. Okay, we are doing 131. What happens when we do 131? That means, look, let's do it in the actual grids that we have. So, in the actual grids that we have, 131 means we go 65 and then another 65, essentially, to the middle of the top, this middle of this grid, middle of this grid, middle of this grid. Okay, so obviously it's bigger than a full grid because we need to be double of a full grid. Is it double of a full grid? No, because it's not even even. So 7386 times 2 is not even similar. Why? Answer is because we're doing a full grid and then 4 quarter grids, but they are not. Wait, no, they should add up to a full grid. There's an off by 1 here somewhere. Because the 131 grid should be. I really need to be able to draw this. Let me try to duplicate my grid. And I'll do it in the silliest way possible. Okay, yeah. I want to see this with my own eyes. What does 131 look like? Uh, just let me see what I did wrong there. J row column. What? Why is this? Didn't work. Oh, wait. Oh, is this where it messes up? Nope. I know this doesn't matter that much, but just wondering why we have weirdnesses in highlight. Oh, I think I know. I think I know exactly why. It's because that. Yep, I knew it. Bug in the library. Okay, so this is 131. Okay, so let's see how. Why is this different than just two full grids? Because so we have, so it's in the middle of these grids, and so this is, huh. I'm still working on it. It's very hard. I don't, I'm not sure what's going on here. So the problem is that this number is not the number I'm expecting. This number is supposed to be uh, the same. Okay, now what I'm trying to say here is if we reshape that diamond, why don't we get two full grids? That's what I'm trying to figure out. Because what we should be seeing, what I thought we should be, but this is not even even. So this is definitely not two full grids, but this is 131, and 131 plus 65 forget what value it is, but it doesn't matter. Well, this okay, this is what we're looking at here. This ginormous diamond. And I need to figure out what are we seeing here. So this is a 3x3 of grids. So let's see. This grid has nothing in it. This grid has a beautiful pyramid. Okay, so let's, again, beautiful pyramid. So this grid has, oh, that's a shape I didn't even think about. Wait, minus 131. No, the grid is size 131, right? So the grid goes all the way from 131 to 0. The original grid is 131 by 131. So, so these are 0 here is the top of the original grid. So this whole thing so you are actually looking at the bottom half. So on that side, it is the bottom right half of the grid. No, wait, there should be, there are only 2 grids in every direction, not 3? No, there are 3. There are 3 in the x direction and 3 in the y direction. And again, so this is where the first grid ends. Okay. Which is kind of weird because it's not. Is that not what I planned? No. Because I looked, 131 plus 65 is the full. Okay. So what I'm looking at, 131 plus 65 fills the entirety of a 3x3. So let's draw this again. Entirety of a 3x3. Middle here, middle here. Middle here, middle here. And cuts all of these in the middle. Cuts all of these in the middle, cuts all of these in the middle, cuts all of these in the middle. And what do you get here? Okay, let's see what we actually got with this. So this obviously is full. The top left quadrant, the middle center one, has, that's not at all what we're, middle center one. So that's from minus 131 to 0 essentially. Well, there should be s's here as well that will help us. There's an S here, S here, and S here. So yes, this one has the bottom right half because there's like a diamond in the center. And again, this is, if we look at the single grid, the only part, so in grid 1, the only part is in the bottom right, which is part 8. So this is an 8. Next, the second one. Second one, it sees everything except 1 and 4. So, okay. So again, so 8 plus f minus 1 minus 4. This one is seeing only section, not 8, 5. This one is seeing f minus 1 minus 3. This one is seeing f. This one is seeing f minus 4 minus 8. This one is seeing 4. This one is seeing f minus 5 minus 8. And this one is seeing 7. So let's see. 8 and 8 cancel. 5 and 5 cancel. 4 and 4 cancel. Okay. That's all I think we have. 1, 2, 3, 4, 5 Fs minus 1, minus 1, minus 3, minus 4, minus 8. Wait, plus 7? There's no minus 7? It's not 7, it's 1. Okay, so that's 5, 8 minus 1, 3, 4, 8. Or it's 4F plus the 65 solution. Let's see if that's correct. Okay, so 4F plus the 65 solution is what I should see here. Okay, what's 4F? 4 times 7386 plus 3751, 33295, 33249. No, but so close. This is ridiculous. This is ridiculous. Why is this wrong but close? This should either be wrong or it should be right, but not wrong but close. So again, 4F. Why is this again? Because so is this too low or too high? What I thought is too high. What if I give it 133? Would that be correct? V4. No, that's well off. 33249. And the correct answer is 33295. Only 46 difference. I'm not sure why this is wrong. Again, let's look at this again. It's like, okay, Okay, let me think about the coordinates. So the original grid goes from row 0 to row 130. Right, right. And in the smack middle of this odd size grid, there is the S. That's what we said here. So, and again, this leftmost grid, the only part that's filled is the bottom right corner. Oh my goodness. There's the even grids and the odd grids and ah, oh my goodness. These are on different because the length is, oh, I hate this. Because the size of the grid is odd, then we have different handedness of these grids and it will never work this way. Okay, okay, okay. This is good. This is good. But that means that in some grids we will color the S. But I don't see this. We're not coloring the S here. We're not coloring any of the S's. Am I not mixing the grids correctly? Modulo 131. The size of the grid is 131. But does this subtly shift the grid one coordinate? Maybe, but it doesn't matter because it has dots on the sides anyway. Wait a minute. Wait a minute. Chord is the... How is this even working? Oh, because I'm correcting them. Okay. My coordinates were originally with S at 0, 0, but then I'm correcting this. Let's instead you know, let's instead just so basically want to put the 0, 0 in the right place. Okay. To do that, all I have to do is put them minus 65. And this will still work. It's not efficient or nice, but it would work. It didn't work. Oh, and then I just removed the remapping here. Yeah, I'm way overthinking this, but yeah. So what we discovered is the problem is there are different polarity grids here. And this is still working. So my code is still working, but my calculations aren't because these grids are on different uh, uh, yeah. So what actually happens here is that these are an odd. Okay, so let's figure out the actual tiles we have. So the tiles that we are playing with are, let's call them A, B, C, D, E, F, G, H, and the ones with prime. Okay, so now let's look carefully what we actually are doing in this case, and then I can figure out. Okay, so ones that are, okay, so we have, I need both the regular and the prime version, so let's set these up. So we have uh, H prime, no, H. This one is F minus F prime minus A prime. F isn't, doesn't, does F matter? Yes, F does matter if it's prime. Minus A prime minus D prime. This one is C, just C, not C prime. This one is F prime minus, okay, actually, let's call it X, because I realize I already have F. X prime minus A prime minus F prime. Okay, this is just X, not X prime, X. X prime minus D prime minus H prime. Okay, this is what? This is D, not prime. This is X prime minus E prime minus H prime, and this is A. Okay, now let's add them up. And they don't seem to cancel out as nicely. So we have, on the non-prime side, we have x plus H plus C plus D plus A. Is that correct? That seems weird. D, H, that shouldn't be C, that should be E. And E and H. Okay, so X plus out. That's what we have here. In the other side, we have 4x prime minus 2a prime, 2d prime, to e prime, and to h prime. Okay, so this is 4x prime minus 2 out prime, right? Right. If we add them together, what do we get? A whole mess. So we have 4x prime plus x plus out plus 2 out prime. Now before we figure out if this is correct, before we do anything else, let's figure out if this is correct. That's what I meant to say. So let's see, out prime, okay, so let's see it this way. Okay, this is 3651. That's the 64 number in prime, okay? And no, I don't want to exit OBS. 740. I can't see this number. 7463. Okay. So now let's see. So if I to make sure that this is correct, so I need 6 times full prime plus full minus in minus 2 in prime. This should give me the correct answer for this case that I'm solving. And it's not the correct answer for everything, but just to figure out if I understand correctly. 6 times full prime. 6 times 7463. Plus full 7386. Minus in 3751. Minus 2 times in prime 3651. Completely off. Not even the right scale, which means I added wrong number of folds. Okay, wait, I did something wrong. Duh, yeah, okay, I know. Hmm. Wait, it's x plus out, right? So x plus out, or 2, yeah, then becomes 2x minus n. It should be even bigger, which is definitely, because, okay, again. HEAD head is that's the regular out plus x. So that's 2x minus n. That's the sum of these. And then the sides, that's just removing two sides. So it's again 4x prime minus 2 minus 2 out prime. So it's 2x prime. Okay. Uh-huh. So it's 2 of these plus 2 of these. Okay. Again, let's do this correctly. We have 4x prime minus 2 out prime. That means 2x prime plus 2 in prime plus 2 in prime. Oh my god, correct. Okay, that is correct. That's the first time we got a correct solution here. Now, the interesting thing here is there's a whole bunch of stuff that cancels out. And yeah, that's the thing that I was worried about. So 7386 plus 7463. That's 14K. That's the entire grid, the number of what is this exactly? That is the size of the entire grid minus the hashes, right? So uh, yeah. So that's just the size of the entire grid minus the hashes. So let's see again. The size of this diamond. So what am I doing here? So the end result is uh, minus n prime. So okay, so 4 times the entire thing. And then I need to subtract once in. Okay. How do we extend this? Now that we understand, now that this works, finally I got a calculation that works. Let's extend it to a bigger size. Because this was for 131 plus 65. Now we do another instance of that. And now we need to figure out how we fold it back to make this work. Thing is, because the grids fold back on each other nicely, I'm just mostly counting full grids, except not exactly. Because you'd expect, but you'd be wrong, because this is actually a little bit awkward. Let's try bigger. The next step is another 131. Let's see what happens when we try to go bigger. Okay, trying to go bigger means that now our universe is in 4 by 4 grids. Yes, it's just 4 grids by 4 grids. It's not that much bigger. Okay, now, no, we need a middle. It's 5 by 5 grids. Okay, it needs to still be odd. Okay, so this is the middle. Okay. Now, yeah, checkerboard it. Okay, checkerboarded it. Now let's see what we have here. So, we have a middle, but then, okay, edges. Let's see. This is empty. This one has uh, H prime. This one has X minus A and D. This one has E prime. Then, next row, this one again has H prime. This one has X minus A. This one is X prime. This is X minus D. And this is X prime minus E. No, my bad. It's just E prime. Again, E prime. Okay, now this is again regular X minus A minus E. This is a full X prime. This is a full X. This is a full X prime. This is again regular X minus DH. Okay? I just want to see a pattern here. This is D prime. This is X minus E. This is a complete X prime. This is an X minus H. And this is a X prime. Sorry, not X prime minus. It's just A prime. GAD prime. Yep. Now, next row is akin to the top row, which would be, and this is, yeah, mistake that there should be a thing here. This would be D prime again, X minus FH, and A prime. Okay, now let's calculate what we have here. On the primes, we have double head prime and quadruple x prime. So 4x prime plus 2 out prime. On the non-primes, that's the primes. On the non-primes, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9? Really? 3, 6. Yeah. Have 9 x's. Right? Yeah. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. 9 x's minus 1 head. Yeah. Minus 3 heads. Okay. So this translates to 6x prime minus 2 in prime. And this is again 3 outs, right? So this would translate to 6x plus 3 outs. And then, okay, again, so this ends up being, which is very similar to the previous ones, and this is where I'm happy, 6 times total instead of 6 times total minus 6 times total minus okay, 6 times total plus minus 2 in prime plus 3 in. Let's choose the math and see if that is correct. 6 times total minus 2 in prime. In prime is 5, 1 plus 3 times in. Is this the correct number? What is the number for? Excellent question. That's 93, 93037, and that was the answer we had, right? No, 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 no. No, don't you dare. Again, this was 5 and 2 131s. That must, okay. 93037. Yeah, I mean, this is showing the middle area, which is correctly represented here. Again, 9335. And what is the correct number? What? Minus 2 in prime plus 3 in. Again, x is the odd one, right? So 6 times total grid. The 6 times total grid, that's the main size of this, right? Because that's the... And then there's the correction. So there are two terms here. The main term is 6 times total grid. Is that? No, because there's two things. The 6 times total grid plus a single out. That's the plus a single in. 9x minus 3 out. Yeah, that's minus x. 2 outs here and 1 out here. So that's 6x and 3 in. Makes sense. And this, with the primes, we have 4 single corners, that's single out, another 4 single corner, that is second out, and 4 complete ones. So 4x plus 2 outs. That also makes sense. And now, to get ins, I'm going to make it 6x minus 2 ins. Okay, yeah, those are all fine. And in prime at 3651. In at 3751. 93045. It's so close, yet it's wrong. Wait, is this the right number? 93037. Let's look at the even. 262. Oh, that means that's 196. We found it exactly right. 3249. But the next one we got slightly off, and this is again just yeah, that's 327. Let me double check that this is not some of my shenanigans here. Wait, 93041 is different than the answer I got before, and that I don't like because this shouldn't have been different. It could be a code answer mistake, not a. That's also wrong. What? Now I can't trust my own code. Oh no. I'm only looking at odd. Something is definitely off here. 32,253. No, this is not the same answer I got before. I don't like this at all. No, this is fine. I think this should still work. Yeah, because it's shifted, I know. Again, and did you get the same answer? 93033253. Is that the? I'm not sure what's going on 14849. Is that the correct number? Yeah, okay. Yeah, 14849 is the correct number. 3751. 3652. 2. Not 51. 52. That's wrong. The S is missing. 3653. Only even eyes. This is wrong. Again, the correct answer is 3651. Right, why do we have an off by one here? Because before we deal with that, again, the even directions we'll need to cover S, and S is not covered here. Why is S not covered here? Because, okay, yeah, because I need to get I from 0. So now this is still wrong. This is 3653. But S is covered here, so what's the mistake? What's the mistake here? Should it go only to 63? 3397, that's definitely wrong. Something weird going on here. Something weird going on here. Okay, what is going on here? Okay, that is the thing. Cause okay, why is this the wrong answer? I want my solution from part 1 back. As you can get anywhere. anywhere that's an odd for thing is, if I don't have the correct answer for part one, the correct answer for part one was supposed to be 3651. But when I run it now on my input, I get 3652. And that's a big problem. 3653. How is adding zero? How is adding zero adding two? That's no, I'm trying to 2 0. Okay, 0 0. That's the first step. Right, okay, then 2 0 minus 2 0. 3653, and if we run this at 3652, okay, it is one difference. So that is correct. Okay. Okay. I'm gonna re-implement this. No, no, no. I don't want to re-implement part one. I really don't. We know this is a diamond. We'll run it on a simple input. How many hard-coded here? I have a lot. A lot of hard-coded stuff. Nice. Mhm. Something is wrong here. Something is obviously wrong here. And it should be simple. So there are two more things. Zero, 64. 0, negative 64, right? So, or I can go 0, negative 64. I can also go to minus 64, 0. All of these have even sums. Because, yeah, this is an even step. So, yeah, the four corners of everything make a grid of XRXC. Grid set. Why is the answer to part 1 wrong? Okay, I'm gonna have to rewrite part 1. Okay, this sucks. Okay, let's rewrite part 1. I don't like doing this, but I'll do it anyway. Start with 65, 65. No, I'll start with 0, 0 because I want to do it with this. Uh-huh. Okay. 1 to 64. That's just a regular loop. Oh, it is out of bounds. It is out of bounds. Maybe? Okay, let me think this through. Let's still do this as is. No, it can't be out of bounds. I'm gonna keep going. Keep going. Okay. Oh no. Redo part 1. Correct answer to part 1. Now, I need to compare it to the wrong answer to part 1 that we get later and figure out why that's wrong. Okay. Now I need fucking yay. It's not a complete grid. Oh my god. Oh my god. It's not a complete. are actual unpassables. Oh. Okay. 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 Fix that bug. 3651 is the answer for 64. For 65, 3751 is correct. Now the full grid is also wrong. 14842. 14842. Fourteen eight four two. Okay. Now 3235. Okay. Oh my goodness. Okay. Now 6 times total minus 2 times 3651 plus 3 times 3751. 93,003. Correct. Okay. Oh my goodness. Okay. We're getting closer here. We're getting closer here. So, okay. Mm-hmm. Okay, so this is now I can do the generic answer. So total is 6. Now why is it 6? So the previous one was, okay, previous one was 2 times total minus n plus 2 n prime. Okay, these are wrong. Let's not. Okay. Okay, good. So this is technically 65 is just the 751, which is in. Okay. Okay, so this is 0. This means 2 times total. This is 1. This is 2. What is the size of this thing? The size of this thing is, so again, no, I don't want to install software. Thank you very much. Thing. so move this here, move that there. This is not even right shape, because this is the middle of a thing, and this is the edge of a thing. So it's a completely wrong thing, but it clearly is. How many full grids? So only half of 20, 12 and a half grids, which is 6 full grids. Okay, that should make sense. 6 full grids. Yeah, because so yeah, this is like 12 and a half grids, so which is 6 and a quarter grids, which is what we get here. 3n minus 2 in tag is indeed 6, because in is, yeah, a quarter grid. So 6 and a quarter grids is what, how much, and this is 2 and a quarter grids. It's a quarter, 2 and a quarter, 6 and a quarter. Now, and the size, so the length here. So this is the base length, right? So because I'm getting 1/2, then 1.5, and then 2.5. Is 2.5 squared 3 and 6 and a quarter? I think it is. Okay, yeah. Okay, so the size, that makes sense, okay? That's the total size. Now let's look at this correction factor. So the total size is indeed so how do you get the number? It's so it's x minus 65 divided by 131. That's the total number here. Now, how do I get these numbers? It seems to be like, yeah, 1, 2, 3, etc. Wait, so okay, so let's see. So I have, let's call it A. A is x minus 65 divided by 131. And for our example, for our actual answer, the answer would be, A would be 2651300 divided by 131, 20238. Okay, now what I'm saying is the correct number is as follows. So it's like a1/4 squared. Oh, no, it's not in a quarter, it's in a half. Okay, it's that and a half squared. That does give me something, .25. Weird. No. Is A odd or even? A is even. So, okay. Now, if A is even, now it's minus A in prime plus A plus 1 times in. Okay? Okay. No! No. No! Okay. Okay. Times 131 plus 65. Oh. Okay. Back to the drawing board. My generalization was not general. Okay. Next, a equals 5. Wait. Okay, so we have that result for all even A's. So what's the problem here? 1, 0, 2, A is wrong. How would you get to this A? Okay. This isn't hard. It's this number. Two zero 2300.
No, I'm not gonna bother with that. What the fudge?